For pretty much all of history, science has been a strictly human thing, a slow, careful climb up a mountain of discovery. But what if that's all about to change, like fundamentally? What if a brand new kind of partner is about to walk into the lab?
And that's really the big question we're digging into today. The idea that a single technology could hit the fast forward button on discovery itself, not just in one field, but across the board. Physics, biology, pure mathematics, you name it.
So to guide us through this, we're actually looking at a fascinating kind of hypothetical research paper. It's set just a little bit in the future, November 2025, and it comes from a collaboration between OpenAI and university researchers. It imagines the very first experiments where a powerful new AI, let's just call it GPT-5, starts to do more than just process data. It starts to think like a scientist.
Okay, let's get into it. The best way to think about this is like we're climbing a ladder of what this AI can do. We'll start at the bottom with the AI as a new kind of partner. Then we'll climb a rung to see how it can rediscover what we already know. And then how it connects that knowledge in new ways. From there, it gets really interesting as it becomes a daily collaborator. And finally, we'll hit that top rung, creating brand new knowledge. And then we'll ask, what's next? So the very first thing we have to wrap our heads around is this huge shift in thinking. The paper's big idea is that we're leaving the era where AI is just a tool, like a fancy calculator or a spell checker, and we're entering a new one where it's a genuine research partner. So the first rung on our ladder is rediscovery. I mean, before an AI can go out and create something new, it's got to prove it can even get to where we are, right? It has to show it can reach the cutting edge of human knowledge all by itself. And this first example, wow, it just captures it perfectly. So you have a theoretical physicist who spends months on this incredibly difficult calculation about black holes. When they gave the same problem to GPT-5 cold, it just failed. But then they tried something different. They gave it a simpler, warm-up version of the problem first. And after that, it turned around and solved the really hard one in just 18 minutes. It shows you that the secret wasn't just raw power, but guiding it, giving it a running start. Okay, here's another one, but this time from a totally different field, immunology. Scientists saw this really weird effect in T cells, but they were stumped. They just could not figure out why it was happening. So they fed the data to GPT-5, and it came back with a totally new mechanism, something the human experts hadn't even thought of. And it didn't stop there. It then predicted that this weird effect could actually be used to make cancer-fighting cells even better, a prediction that, by the way, was later proven right in the lab. This is way beyond just rediscovery. This is the AI generating brand new, testable ideas.
All right, let's climb to the next rung. This is where things start getting really wild. We're talking about connecting knowledge. See, the AI has this incredible ability to look across all these different fields of science that are usually stuck in their own little bubbles. It's like a universal translator for scientific ideas. Just look at this number, 10. That's how many famous, super hard math problems that were still listed in a major database as unsolved, that GPT-5 found solutions for. The solutions were already out there, just buried in decades of obscure papers from completely different fields written in totally different jargon. And the crazy part is how it does this. The authors put it perfectly. As a human, you're stuck guessing keywords for a search engine. You have to hope you use the exact right phrase. But GPT-5 doesn't need keywords. It understands the concept of the problem. It means it can see that a problem described in the language of, say, fluid dynamics is actually the exact same problem that was solved in computer science years ago. It's incredible. But, and this is a huge but, this power comes with a pretty serious warning. The paper tells this story about a research team that was just ecstatic. GPT-5 had given them this beautiful, elegant proof for a really tough problem in coding theory. They thought they had a major breakthrough on their hands. And then they found out that the AI's proof was a carbon copy of one published by a mathematician named Noga Alon almost 3 years earlier. The AI found it, yes, but it didn't cite its source. It just presented it as new. This highlights a massive challenge. Human verification is more crucial than ever. We have to be the ones to check the work and give credit where it's due. Climbing higher now, we get to the AI as a daily collaborator. This is where it stops being a special occasion tool and starts becoming, well, part of the team. It's like having a tireless research assistant and a brilliant sparring partner available 24/7. The famous mathematician Timothy Gowers puts it perfectly. He basically says he uses the AI as a reality check. Instead of spending weeks or even months chasing an idea that's a dead end, he can just run it past the AI and get an immediate explanation for why it won't work. So, for example, Gowers had this idea for creating a special kind of graph. He proposed it to GPT-5, and almost instantly, the AI came back and pointed out a fatal flaw in his logic, something about its matrix rank being too low. That kind of instant feedback loop is an absolute game changer. It saves an unbelievable amount of time. And if you want to see just how much of a game changer, look at this. In a super complex thermonuclear physics problem, a workflow that would normally take a team of experts 6 months to complete was done in 6 hours with an AI partner. That's not just an improvement, it's a fundamental transformation in the speed of science.
And that brings us to the very top of the ladder. This is the big one. This is the most profound step of all, where the AI moves beyond just finding and checking human knowledge to actually helping create genuinely new discoveries.
Now, to really get the weight of this, you have to know what an Erdos problem is. Think of them as legendary, unsolved puzzles in mathematics posed by one of the greatest mathematicians ever. Solving one is a really big deal. And the paper reports that a team of mathematicians, working hand in hand with GPT-5, did it. They solved a previously unsolved Erdos problem, resulting in a brand new, verified mathematical theorem. And this wasn't just a fluke, right? In total, the paper documents 4 new mathematical results. But here's the absolute kicker. In one of those cases, the core creative idea, that spark of insight that cracked the whole problem open, came directly from GPT-5. That's the moment the AI graduates from being an assistant to being a true creative contributor. So, where does all this leave us? We've climbed this entire ladder, from the AI just rediscovering old facts, all the way up to it contributing to brand new theorems. It seems pretty clear this new partnership between humans and machines is about to completely redefine the future of science. And this really lays out the new dynamic. On one side, you have the AI's strengths. It's tireless. It can search everything ever written. It can spot logical flaws in an instant. But this doesn't make the human obsolete. It actually makes the human role more important. Our job shifts to what we do best, asking the big questions, providing that deep expertise and intuition, and ultimately setting the creative and ethical direction of the research. Each side makes the other better. And this all boils down to one final fascinating question. As our tools stop being just passive instruments and start becoming active partners in the active discovery, we have to ask a new question. Who or what is the scientist now? And when a breakthrough happens, who really gets the credit?